Hi friends, welcome back to our channel Physics Tutorial. Today we are going to revise a new chapter of plus 2 physics, that is alternating current. Here we have to study some equations, derivations and all, and if we know the basic ideas about alternating current, it will be very easy to understand the concept. Okay, so we can just go through those basic ideas and then we can revise the chapter. Are you ready? Now we have alternating current. What is alternating current? You might have learned about alternating current. Even if you don't remember that, it's not a problem at all. We can just start with the basics. So here the electric current means the current whose magnitude changes with time, whose magnitude will be changing with time and direction reverses periodically. It is called alternating current. Here we can see the direction of the current. Here the direction of the current is varying periodically. Okay, and the magnitude also changes with time. As the time increases, the magnitude is changing, also the direction changes periodically. So this is called an alternating current. So here we will represent the AC or alternating current as a sinusoidal wave, or means just like this. Okay, so here we can see the electric current, that is alternating current. So the electric current whose magnitude changes with time and direction reverses periodically, it is called alternating current. And that the instantaneous voltage can be represented as V is equal to Vm sin omega t. Instantaneous voltage means the voltage at any instant. So that can be represented as V is equal to Vm sin omega t, because this is a sinusoidal function. So this is very important thing, that how we can represent the instantaneous voltage, and these things you have to remember. That is, V is the instantaneous voltage. Then what is Vm? Vm will be the peak value or the maximum value of voltage. Here we can see this is, here we are taking voltage or current. So here the peak value will be Vm. That is the peak value of voltage. Vm is represented here. This will be the maximum value or peak voltage. Then V is the instantaneous voltage. Okay. And then if you are considering current, so current is also in the same way. I is equal to Im sin omega t. Here I will be the instantaneous current and Im is the peak value of current. Okay, so this is the instantaneous voltage, current, and this is the peak current. And this diagram that we will use always. Okay, so the representation you have to understand. Then suppose we are taking this complete cycle. So this is one cycle. Okay, here how we can find the average value of this? Average value of this AC. So what will be the value? Suppose here we are having some values, and here also we are having the similar values of negatives. So if you are taking the total or average, what will happen? That will get cancelled, right? Here positive values are here, and here the similar negative charges are there. So this will get cancelled. So in order to avoid that, what we will do is we have to find the RMS value of AC. RMS means root mean square value. Root means square value. Root means square. So that is very important. That means we have the average value of sin omega t is equal to 0. Then average value of cos omega t is also equal to 0. And sin square omega t, average value of sin square omega t is equal to 1 by 2, and average value of cos square omega t is equal to 1 by 2. That how we are getting is, here we will be having some values. Suppose 1, 2, 3, etc. 1, 2, 3, 4, like that. Okay, here corresponding negative values will be there. So minus 1, minus 2, minus 3, etc. Okay, minus 4. So 4 values are taking on the positive side, and here 4 values in the negative side. Okay, then if you are taking the average, what will happen? The total will be 0. If you are taking the square, first of all we can square all these values. So this 1, 2, 3, 4 means all are negative, right? If you are taking the square, that will be positive. And here also the positive values we have. Then we can take the mean of that. then find the root. That is called root mean square value. That means it will not be 0. So otherwise the average value of, this is also very important thing, that is average value of sin omega t is equal to 0 and average value of cos omega t is equal to 0. Hope it is clear to you. Here we have positive values, here the corresponding negative values. So if you are taking the average, that will get cancelled. Clear? So before avoiding that thing, what we will do is, here we will take the square of these numbers, then we have to find the mean of that, then calculate the root. That is called RMS value. That means root mean square value. So that is very important thing. And if you are finding the average value of sin square omega t, that will be half. And thus average value of cos square omega t is also half. So these four values are very important that you have to remember. And one more thing is, the RMS value of voltage can be written as Vm by root 2. Okay, so that Vm by root 2 is the RMS voltage and IRMS is the RMS value of current. That means the root mean square value of current, that is also equal to Im by root 2. Here Vm and Im are the peak values of voltage and current. So these things you have to remember. Then one more thing is that phasors. Phasors means the rotating vector. So in this case we will represent the scalars in terms of vectors. That means as phasors we have to represent. That means the rotating vector. The phasor means the rotating vector. So here we can consider an example, then it will be more clear, because in all the cases we will draw the diagram of phasors. Okay, so don't worry about that. Just I will explain how to make it a rotating vector. So here suppose V is equal to Vm sin omega t. This sinusoidal wave we are considering here. So here we are having V is equal to Vm sin omega t. So we will represent it as a sinusoidal wave. This is the representation of V is equal to Vm sin omega t. Here we have 0, pi by 2, pi, 3 pi by 2 and 2 pi. This is a complete cycle. Right. So here we can't rotate these values. Okay, here it is not easy to rotate the things. So here instead of this representation we are bringing it into a rotation. Here we can see these two axes is there and here we are taking the angle omega t. This is the angle omega t and Vm is represented here. So here the angle between this omega t is shown here. So this is 0 and in between 0 to this value, that is omega t. And suppose we want to change this omega t plus pi by 2, what we can do? We can rotate this. Okay, so this will be plus pi by 2 like this. We can rotate the whole into 2 pi. Okay, so that means now it is becoming a rotating vector. So after getting the phasor, we have to consider it as a vector. So is it clear? Because vectors means the rotating vector. So here we will consider it as a vector and by an angle omega t we can rotate the vector. So that is the representation in case of a phasor. Okay, so all these are the basic things that you have to know before starting the chapter. So here the points you have to remember is, first one, what is alternating current? That is the chapter. So you have to know what is alternating current or AC. That is the electric current whose magnitude changes with time and direction reverses periodically. Okay, so that is called alternating current, and here we can represent the instantaneous voltage by using the equation V is equal to Vm sin omega t. And current also I is equal to Im sin omega t. Here V is the instantaneous voltage and Vm is the peak voltage or the maximum voltage, and the current is also in the same way. Okay, now we have to know how to represent a AC current. Okay, then RMS value of AC. I think that idea is clear to you, because why we are taking the root mean square value, because the average of sin omega t is equal to 0, then average of cos omega t is also equal to 0. If you are taking the complete cycle of an AC, the average value will be 0. So for avoiding that, we are taking the root mean square value of that cycle, okay, so of that AC. So here we are getting sin square omega t is equal to 1 by 2 and cos square omega t is equal to 1 by 2, and Vrms is equal to Vm by root 2 and Irms is equal to Im by root 2. So these equations are very important. And the last thing what we have told is phasors. Phasors are the rotating vector, so that will be represented as rotating vectors by an angle omega t. Okay, so all these are the basic things. Now we can move to the portion. Now we can move to the first topic, that is AC applied to a resistor. So here we have an AC circuit which is connected to a resistor only. So here we can see that V is equal to Vm sin omega t is the voltage applied to an AC circuit. Okay, so here current is flowing in this direction and only the resistor is connected here. So the applied voltage we can write, that is the instantaneous voltage can be written as V is equal to Vm sin omega t. And here whenever we consider an AC circuit or capacitor, so here in the next case we have to study about AC applied to a capacitor and inductor, like that. Okay, so in all these cases we have to do that 5 steps. So the first one is, here we will write the voltage. Voltage will be given here, right? AC voltage will be given, and the corresponding current we will calculate. So that current we have to calculate, and then we will find the relation between voltage and current. So that is the second step. And in the third step we have to draw the graph between this V and I. And in third case we will draw the phasor diagram of this, and in the fifth case the average power we have to find. So the same steps we will follow in all the cases, that means resistor, capacitor, inductor, then LCR circuit and all. Okay, so if we understand this only the first resistor, it will be easy to do the similar steps in the next cases also. So just understand the things clearly. Okay, so here first of all we will find the value of current, then relation between voltage and current, that means the phase difference we will find, then graph we have to draw between V and I, then phasor diagram that we have just told, right, that rotating vector we will draw, then the average power we have to calculate. So these are the steps we are going to do with this. So first of all we have the instantaneous voltage, that is V is equal to Vm sin omega t. Now we have voltage. Then our first step is to calculate current. So how we can calculate current from this equation? We can use Ohm's law, right? That is, resistance is here, then voltage is here. So Ohm's law, V is equal to IR. So I will be equal to V by R. We can just substitute the value of instantaneous voltage, that is V is equal to Vm sin omega t by R. Clear? So what is Vm by R? That is Im. Vm by R is equal to Im, right? So what will be the equation? I is equal to Im sin omega t. This is the equation for current. So our first step is over now. So what we have to do here, voltage was there, then current we are finding by using Ohm's law. V is equal to IR, then I will be equal to V by R. Okay, then instead of V we can write Vm sin omega t, that is the instantaneous value of voltage, and divided by R. So what we will get, Vm by R is equal to Im. So the equation for current will be I is equal to Im sin omega t. Right, now what we have to do, relation between V and I we have to find. So finding the relation between V and I, we can consider the two equations. First one is V is equal to Vm sin omega t, and the second equation I is equal to Im sin omega t. These two equations we have to consider. Here we can see this omega t is the phase of this voltage. Okay, and here also the current also has the same phase, that is omega t. Right, so how we can find the relation between V and I? Both are in same phase. Okay, there is no phase difference. That means here the current and voltage are in same phase. Clear? So second step is also over. Now we have to draw the graph between V and I. So V and I means, for omega t, what we have to do is we will give the values of 0, pi by 2, pi, 3 pi by 2 and 2 pi. Here we have V is equal to Vm sin omega t. So in this equation we will give the values of omega t, that is for voltage what we will get here, V is equal to, when we are giving 0, so 0, pi by 2, pi, then 3 pi by 2, 2 pi. All these values we are giving. We can just write the values here. Then it will be easy to draw the graph. So how we can find? Just give 0 for omega t. So sine 0 is 0, right? So total value voltage will be 0. Then in the next case, pi by 2, value is sine pi by 2, 1. So 1 into Vm. Then next again pi, again 0. Okay, here then 3 pi by 2, that is minus 1. Minus 1 into Vm, that is minus Vm. Then 2 pi means sine 2 pi, 0. So again 0. In the similar way, we can find the current also. Current is also having the same phase, right? So the similar values we will get. So I will be here for 0, the current is 0. Then for pi by 2, current will be Im. Then pi 0, 3 pi by 2 minus Im, then 2 pi 0. So now we have to draw the graph. Here we can mark this 0, pi by 2, pi, 3 pi by 2 and 2 pi. And here we can start from here. First of all, we can draw this voltage. Okay. So for 0, the value is 0. So here we can draw this mark. And for pi by 2, what is the value? For pi by 2, it is Vm. Vm means maximum value or peak value of voltage. Here we can mark this peak value of voltage. Okay. And then for pi, again it is 0. And then minus Vm. And for 2 pi, it is 0. So the graph will be like this. Okay, now we are getting a sinusoidal wave. And in the next case, what will happen? Current. Now, current, how will be the magnitude? Here we can see Im is equal to Vm by R. So, automatically we can understand that it will be less than Vm, right? By R we are doing here. So, we can draw the magnitude a little less than that voltage. So here in the similar way we can draw that. So the graph will be just below that we are showing only because of this. Okay, magnitude will be a little bit lesser than voltage. Okay, so that is all about the graph. Now we have to move to phasor diagram. How we can find the phasor diagram? Phasor diagram means here again we have to look into the two equations. V is equal to Vm sin omega t and I is equal to Im sin omega t. Here these two are having the same phase, right? So how we can draw? First of all, we have to draw these two. Then how we can draw voltage? Here voltage is V is equal to Vm sin omega t. So here we have the angle omega t. Right, so V, the magnitude is marked here, V. Then what about current? So in the same way, because in the same diagram we have to mark current also. So Im sin omega t again. So I will be a little bit less than voltage, right? So the magnitude we can mark over here and sin omega t itself. So the angle will be the same. So here itself we can mark. Clear? So when we find the next case, it will be very easy to understand the difference. Here we are getting the same angle. That is why we mark both in the same line. Okay, here we have a vector, that is V, and here this is the current vector. Okay, so that is phasor diagram, and we have the maximum value of voltage at this point, that is Vm sin omega t, and this point means Im sin omega t. So this is the phasor diagram. So that is one more thing we have to discuss is average power, so that we can discuss now. Before that, you just remember or means understand all these points. That is current means I is equal to Im sin omega t. Then relation between V and I, that is I and V are in same phase. Current and voltage are in same phase. And third one, graph. So when we draw the graph, we have to give the value 0, pi by 2, pi, 3 pi by 2 and 2 pi to omega t. So in all the cases, we will be following the similar steps. That is why I am repeating that. Okay. So omega t means here we have to give values, then V and I separately we will find, and then we can draw the graph. Okay, here we can see that there is no phase difference between these current and voltage, and the phasor diagram we have to draw. That is, here we have to mark both the current and voltage in a single graph. So here we are getting the omega t as the angle. Then here we can rotate it continuously, because throughout this angle we can rotate this. Okay, so that is phasor diagram. Now we can discuss average power. Now we have to calculate the average power. So that is the last step of this. Okay. So here how we can find the instantaneous power. The equation for power is P is equal to I square R we can use. Okay. I value is the instantaneous value of current. That equation we already have. I is equal to Im sin omega t. Right. That we can substitute in this equation. Then what we will get? P is equal to Im square sin square omega t into R. Okay, so that is the equation of power. P is equal to Im square sin square omega t into R. Now we have to find the average power. So for finding average power, we can take the average of Im square sin square omega t into R. Right. Now what are the constants coming here? Im is the maximum value or peak value of current, that is a constant. Then R is a constant, right? So these two we can take outside. So P will be equal to that means average power will be equal to Im square R, then average value of sin square omega t. And in the beginning, we have already told that the value of average value of sin square omega t is equal to 1 by 2. So for sin square omega t, we can substitute the value of 1 by 2. Then what we will get? P is equal to Im square R by 2. That is into 1 by 2. So Im square R by 2 we can write. And here we have Im by root 2 is actually IRMS, right? So can we split this Im square by 2 as Im by root 2 into Im by root 2, then that will be Im by root 2 the whole square, right? So here we can write this Im square by 2 as Im by root 2 the whole square into R. Then what we will get? Im by root 2 is IRMS. Root means square value of current. Okay. Then that IRMS square into R, that is the average power. That is P is equal to IRMS square into R. So that equation you have to remember. So here how we can find the average power? We can use the equation P is equal to I square R, and we substitute the instantaneous value of current. I is equal to Im sin omega t. So Im square sin square omega t into R, and here we are taking the constants outside. Then average value of sin square omega t is 1 by 2, that we are substituting here. So Im square R by 2, and we split this into 2, Im by root 2 the whole square. Then that will be equal to IRMS square into R. That is average power is equal to IRMS square into R. So that is all about AC applied to a resistor. So in the next case we have to consider AC applied to a capacitor. So that in the next class we can discuss. Okay. So hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.